Hello, dear viewers, we appreciate your continuous support and your curiosity about programming. Today, we're diving into the fascinating world of object-oriented programming, or OOP. It's a programming paradigm that's integral to modern software development and a must-know for aspiring coders. In this video, we'll break down OOP into easy-to-digest sections. We'll begin by exploring what object-oriented programming is and how it stands apart from other programming approaches. We'll travel through its fundamental concepts, including classes and objects, and the big three: encapsulation, inheritance, and polymorphism. Along the way, we'll pepper in practical examples to bring these abstract ideas to life. This journey is designed to equip you with a solid understanding of OOP, setting a firm foundation for more advanced topics. So buckle up, it's going to be an enlightening ride. In the next segment, we will delve into the fundamental concepts of OOP. To start, let's define object-oriented programming and how it sets itself apart from other programming paradigms. At its core, object-oriented programming, or OOP, is a design philosophy that organizes data and functions into units called objects. Each object is an instance of a class, which can be thought of as a blueprint for creating similar objects. Now let's discuss the three main principles of OOP: encapsulation, inheritance, and polymorphism. Encapsulation is the bundling of data and functions that manipulate that data. Inheritance allows new objects to take on properties of existing objects. And polymorphism lets the programmer use one type of entity in many forms, making code more flexible and intuitive. Think of a car. The car is an object derived from the car class, with properties like color and model, and functions like accelerate and brake. That's OOP in a nutshell. With these fundamentals, we can now explore the advantages and practical applications of OOP. Object-oriented programming has many benefits that make it a go-to choice for many developers. Let's delve into these advantages. Firstly, the ease of code maintenance. OOP's structure means that if a change is required, it can usually be made in a single place, rather than having to update code throughout your project. Secondly, code reusability. An object created for a program can be reused in other programs, saving time and effort. Then we have flexibility and scalability. With OOP, developers can create new objects, attributes, and methods as their project grows, making it a great choice for complex, evolving projects. Now let's consider some real-world applications. OOP is used in web development, game design, and even scientific simulations. Companies like Facebook and Google use OOP principles in their products, proving its practicality and effectiveness. Now that we understand the benefits and applications, let's look at popular programming languages that use OOP. Several languages use the object-oriented paradigm, each with its unique features. Let's shine a light on a few of them. Java, a stalwart in the world of OOP, is renowned for its write-once, run-anywhere philosophy. It's widely used in enterprise-level applications and Android development. C++, on the other hand, is the go-to for system programming, game development, and other performance-intensive tasks. It offers a blend of high-level and low-level features, granting developers a great deal of control. Python, with its simplicity and readability, is a favorite among beginners and experts alike. It's used extensively in data analysis, machine learning, web development, and more. These languages, while all object-oriented, have different strengths and are suited to different tasks. It's akin to choosing the right tool for the job. To illustrate, let's implement a simple program, a hello world, in Python. It's as easy as typing print, hello world. Before we wrap up, let's talk about some best practices in OOP and useful resources. As with any programming paradigm, there are best practices to follow in OOP. Naming conventions for classes and methods, for instance, plays a crucial role in enhancing code readability. It's also pivotal to keep your code organized. Group related classes and functions together, and avoid clutter. Be on the lookout for anti-patterns. Those common approaches that seem helpful but can lead to inefficiency or code that's difficult to maintain. In terms of tools, there are several integrated development environments, or IDEs, that can streamline your OOP journey. Eclipse, IntelliJ IDEA, and Visual Studio Code are just a few examples. For further learning, books like Head First Java or Python Crash Course are great resources. Online platforms such as Code Academy and Coursera also offer comprehensive courses on object-oriented programming. And that's a wrap on our journey into object-oriented programming.